This is a pair of linear equations in two variables. Till now, we have solved a pair of linear equations in two variables and obtained a unique solution. Let us see what solution do we get for this pair. So let us solve it by elimination. The coefficient of x in the first equation is 2 and in the second equation it is 1. The coefficient of y in the first equation is 2 and in the second equation it is 1. So we need to make one of the coefficients numerically equal to the first equation. So let us multiply this equation by 2. So 2 into x gives us 2x plus 2 into y gives us 2y is equal to 2 into 9 gives us 18. So this is what we have. 2x plus 2y is equal to 18. This is obtained by multiplying this equation, that is by multiplying both the sides of this equation by 2. Now we need to solve these two equations. So these two equations, this says 2x plus 2y is equal to 18. But from the first equation we have 2x plus 2y is equal to negative 5. So is this ever possible? No, this is not possible. 2x plus 2y would either be 18 or be negative 5. It is not possible to have a value of x and y for which both the equations are satisfied. So there is no value of x and y for which both these equations will be satisfied. So we say that this pair of linear equations has no solution. That is, no value of x and y satisfy this as well as this, because 2x plus 2y would either be negative 5 or be 18, but this is a contradiction. So what is there in this pair of linear equations that it has no solution? So let us come back to our original equations, that is this, and compare it to the general form. In the general form, we have all the terms on the left hand side and a 0 on the right hand side. So let us transpose the terms on the right hand side of these equations to the left hand side. So we get 2x plus 2y plus 5 equal to 0 and x plus y minus 9 equal to 0. Now let us compare these two with these two. So we have a1 is equal to 2, b1 is equal to 2, c1 is equal to 5. We have a2 is equal to 1 because the coefficient of x is 1. b2 is equal to 1 because the coefficient of y is 1. And c2 is equal to negative 9. This is what we have. Now let us divide these. So we get a1 by a2 is equal to 2, b1 by b2 is equal to 2, and c1 by c2 is equal to 5 by negative 9. So a1 by a2 is 2, b1 by b2 is 2, and c1 by c2 is 5 by negative 9. This ratio is equal to this ratio, that is a1 by a2 is equal to b1 by b2. But these two are not equal to this. So we have this condition, a1 by a2 is equal to b1 by b2, not equal to c1 by c2. And whenever we have a pair of linear equations in which the coefficients and the constant term satisfy this condition, that pair of linear equation will have no solution. So if a pair of linear equations satisfy this condition, then that pair will have no solution. Now look at these two equations. Once again, the coefficient of x here is 2, coefficient of x here is 1, coefficient of y is 2 and y is 1. So in order to solve these, we need to multiply this by 2. So we get 2x plus 2y is equal to 10. We have multiplied both the sides of this equation by 2. Multiplying the left hand side, we get 2x plus 2y. Multiplying the right hand side, we get 10. So 2x plus 2y is equal to 10. So now we need to solve these two. But these two are essentially the same equations because both of them say that 2x plus 2y is equal to 10. So these are actually the same equation. And we know that a linear equation in two variable has infinitely many solutions. So this system of equations has infinitely many solutions. Now what is so special about this system of equations that it has infinitely many solutions? Let us come back to our original pair of equations and once again compare it to the general form. Now bring all the terms on the right hand side to the left hand side by transposing. So this becomes 2x plus 2y minus 10 and this becomes x plus y minus 5. 2x plus 2y minus 10 equal to 0. X plus y minus 5 equal to 0. Now let us compare this pair with this pair, which is the general form of a system of linear equations. So we have a1 is equal to 2, b1 is equal to 2, c1 is equal to negative 10. We have a2 is equal to 1 because the coefficient of x is 1. b2 is equal to 1 because the coefficient of y is 1. And c2 is equal to negative 5. Now let us divide this. So we divide a1 by a2 to get 2. 2 by 1 is 2. We divide b1 by b2 to get 2. We divide c1 by c2. So that is negative 10 by negative 5. Negative negative get cancelled. 10 by 5 gives us 2. So we have these three ratios. And we see that these are the same. The ratio of A1 and A2 is the same as that of B1 and B2, and it is the same as that of C1 by C2. So we have this condition, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So whenever we have a system of linear equations which satisfies this condition, then we can say that that system of linear equations has infinitely many solutions. So this system satisfies this condition and hence it has infinitely many solutions. So now let us look at this pair of linear equations in two variables. X and y are the variables. A1, A2, B1, B2, C1, C2 are constants. So this is the general form of a pair of linear equations in two variables. Now let us look at the ratios. So first let us look at this part. So A1 by A2, this is one ratio. What is the second ratio? B1 by B2. Now these two ratios can either be equal or be unequal. So A1 by A2 will either be equal to B1 by B2 or it will be unequal. So these are the two possibilities which we may have, equal or unequal. Now if these two ratios are not equal, then the system of equations will have a unique solution. So we will have one value of x and one value of y for which these two equations will be satisfied. And then the system is said to be consistent. Why consistent? Because there exists some value of x and y for which the equations hold. That is, for which the equality is true. So if a1 by a2 is not equal to b1 by b2, then the system of equations has a unique solution. But what if it is equal? So if a1 by a2 is equal to b1 by b2, let us come to the third ratio, which is c1 by c2. Now, these two can either be equal to this or be unequal. So we can have a1 by a2 equal to b1 by b2 equal to c1 by c2, or we can have a1 by a2 equal to b1 by b2 not equal to c1 by c2. These are the only two possibilities which we can have. If all three are equal, then the system of equations will have infinitely many solutions and it is said to be consistent. So if all three ratios are equal, then this system of equations has infinitely many solutions and it is said to be consistent because although there are many, but there are values of x and y for which the equations are true. That is, for which the equality holds. If this is the case, then the system of equations have no solution. That is, it is inconsistent because there is no value of x and y for which both the equations will be satisfied. That is, there is no value of x and y for which both the equations will hold true. So these are the conditions for unique solution, infinitely many solutions, and no solution in a pair of linear equations in two variables.